ellipse. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. The two fixed points are called the foci, plural of focus, of the ellipse. We can see that P1F1 plus P1F2 equals to P2F1 plus P2F1 equals to P3F1 plus P3F2. The midpoint of the line segment joining the foci is called the center of the ellipse. The line segment through the foci of the ellipse is called the major axis, and the line segment through the center and perpendicular to the major axis is called the minor axis. We denote the length of the major axis by 2a, the length of the minor axis by 2b, and the distance between the foci by 2c. Thus, the length of the semi-major axis is a and semi-minor axis is b. Note: the constant, which is the sum of the distances of a point on the ellipse from the two fixed points, is always greater than the distance between the two fixed points. Relationship between semi-major axis, semi-minor axis, and the distance of the focus from the center of the ellipse. Take a point P at one end of the major axis. Sum of the distances of the point P to the foci is F1P plus F2P equals to F1O plus OP plus FP equals to C plus A minus C equals to 2A, since F1P equals to F1O plus OP. Take a point Q at one end of the minor axis. Sum of the distances from the point Q to the foci is F1Q plus F2Q equals to root B square plus C square plus root B square plus C square equals to 2 times root B square plus C square. Since both P and Q lies on the ellipse, by the definition of ellipse, we have 2 root B square plus C square equals to 2A, or we have C square equals to A square minus B square. Special cases of ellipse. In the equation C square equals to A square minus B square obtained above, if we keep a fixed and vary C from 0 to A, the resulting ellipse will vary in shape. Case 1. When C equals to 0, both foci merge together with the center of the ellipse and A square equals to B square, that is A equals to B, and so the ellipse becomes circle. As you can see, both F1 and F2 coincide in this case. Case 2. When C equals to A, then B equals to 0. The ellipse reduces to the line segment F1, F2 joining the two foci. Eccentricity. The eccentricity of an ellipse is the ratio of the distance from the center of the ellipse to one of the foci and to one of the vertices of the ellipse. Eccentricity is denoted by E, that is, E equals to C by A. Standard equation of ellipse. The equation of an ellipse is the simplest if the center of the ellipse is at the origin and the foci are on the coordinate axis. The two such possible orientations are shown in. Let us derive the equation for the ellipse shown above in with the foci on the x-axis. Let F1 and F2 be the foci and O be the midpoint of the line segment F1, F2. Let O be the origin and the line from O through F2 be the positive x-axis and that through F1 as the negative x-axis. Let the line through O perpendicular to the x-axis be the y-axis. Let the coordinates of F1 be minus c 0 and f2b c 0. Let P of xy be any point on the ellipse such that the sum of the distances from P to the two foci be 2a. So given P f1 plus P f2 equals to twice a. Using the distance formula we get root of x plus c square plus y square plus root of x minus c square plus y square equals to 2a. Root of x plus c square plus y square equals to 2a minus root of x minus c square. Squaring both sides we get x plus c square plus y square equals to 4a square plus root of x minus c square minus 4a root of x minus c square. On simplification, it gives root of x minus c square plus y square equals to a minus c by a into x. Squaring again and simplifying, we get x square by a square plus y square by b square equals to 1, since c square equals to a square minus b square. This is the equation of ellipse with the center at the origin and major axis on x-axis and minor axis at y-axis. Observations. From the equation derived above, we can have following observation. First, ellipse is symmetric with respect to both the coordinate axes, since if xy is the point on the ellipse, then minus x, y, x minus y and minus x minus y are also point on the ellipse. Second, the foci always lie on the major axis. The major axis can be determined by finding the intercepts on the axis of symmetry. That is, major axis is along the x-axis if the coefficient of x square has the larger denominator, and it is along the y-axis if the coefficient of y square has the larger denominator. The equation of other form of ellipse can be obtained similarly as shown in the table. Latus rectum. Latus rectum of an ellipse is a line segment perpendicular to the major axis through any of the foci and whose endpoints lie on the ellipse. Let us find the length of the latus rectum of the ellipse. X square by a square plus y square by b square equals to 1. Let the length of AF2 be L. Then the coordinates of A are C, L, that is AE, L. Since A lies on the ellipse, we have AE square by A square plus L square by B square equals to 1. Simplifying, L square equals to B square into 1 minus E square. But E square equals to C square by A square or 1 minus B square by A square. Putting this in above equation, we get L square equals to B to the power 4 by A square, or we can say B square by A square. Since the ellipse is symmetric with respect to y-axis, of course it is symmetric with respect to both the coordinate axes. AF2 equals to F2B, and so the length of the latus rectum is B square by A square. Example. Find the equation of the ellipse with major axis along the x-axis and passing through the points 4, 3 and minus 1, 4. Solution. The standard equation of ellipse is x square by a square plus y square by b square equals to 1. Now, it passes through 4, 3 and minus 1, 4 it gives, and solving both equation, 16 square by a square plus 9 square by b square equals to 1 and minus 1 square by a square plus 16 square by b square equals to 1. We have a square equals to 247 by 15, b square equals to 247 by 7. Now the equation becomes 7 square plus 15y square equals to 247. Example: a rod AB of length 15 cm rests in between two coordinate axes in such a way that the endpoint A lies on x-axis and endpoint B lies on y-axis. A point P of xy is taken on the rod in such a way that AP equals to 6 cm. Show that the locus of the P is an ellipse. Solution: let AB be the rod making an angle theta with OX as shown, and P of xy the point on it such that AP equals to 6 cm. Since AB equals to 15 cm, we have PB equals to 9 cm. From P, draw PQ and PR perpendiculars on y-axis and x-axis respectively. From triangle PBQ, cos theta equals to x by 9. From triangle PRA, sin theta equals to y by 6. And since cos theta square plus sin theta square equals to 1, we have x square by 81 plus y square by 36 equals to 1. This is the locus of P, which is the ellipse.